In this lesson, we are going to find out more ways of measuring an angle. Let's consider this circle. I can cut this circle into 4 equal parts. I can also cut this circle into 8 equal parts. If I cut the circle into 8 equal parts, then I am getting one part which looks like this. This part of a circle between two radii and part of the circumference is called a sector. The shape of a sector looks like a pie. Two sides of the sector are the radii of the circle, and this is the angle of the sector. So these two are radii of the circle, and this is the arc which makes the sector, and this is the angle which again makes a particular sector. I can go on cutting the circle into more sectors like this. Each sector is equal in the sense that they have equal angles and equal arc length. So here the length of the arcs in each sector, they are the same, and the angles they make are all the same. I can continue cutting the circle into 360 parts. Each part has a sector, looks like a sector in this way. This sector is a special sector because the angle made by this sector is called a degree, which leads to say that we have 360 degrees now in this circle. So when we continue going on with 1 degree each in each sector, then we have 360 degrees in a circle. Therefore, this sector, which is part of 360 sectors, has a degree as its angle. So what is a degree? When a circle is cut into 360 equal sectors, the angle subtended, which is made by each sector, is called a degree. Let's continue the same concept further. Consider this circle. I have a sector here in which the radius of the circle is equal to the arc length. If I make a sector in this way where the radius of the circle is equal to the length of the arc of the sector, then the angle formed here is named 1 radian. So a radian is a measure of angle of a sector in which the radius of the circle is equal to the length of the arc of the sector. I can have more sectors like this. Each sector has angle 1 radian. The radian is the angle when the sector has the arc length equal to the radius. So what is a radian? When a circle is cut into sectors such that the arc length is equal to the radius of the circle, the angle subtended by each sector is called a radian. What happens if the radius changes? Here I have 4 different circles with different radii. Let's see what is the center of all the 4 circles. So the center of the circles lay here. So this was the center of the circle. Let me take the radius of the smallest circle, and then let me take an arc on the circle which is equal to this radius, and then make a sector. So this sector obviously should have 1 radian measure. So 1 radian is either written as 1 rad or just simply 1. If I write just 1, it means that it is measured in radians. So this is 1 radian measure of an angle. Let me continue getting the same pattern in the next circle. Let me get the radius of the next circle and then measure the equal amount in the arc and make a sector. We can see that the angle remains the same. Let me continue with the third circle. Again, we can see that the angle remains the same. If I take the fourth circle and make the same way, the sector has the same angle. So whatever the radius is, as long as we take this arc length as equal to the radius, the sector makes 1 radian angle. Usually 1 radian angle is equal to 57 degrees approximately. Let's consider a circle here and a sector which has the angle of 1 radians. This is 1 radian. So that means if this is the radius of the circle, then the length of the arc is actually equal to the radius of the circle. This and this are equal. In fact, all the three are equal. Now, the length of the arc, which is L, is equal to the radius of the circle when the angle is 1 radian. What happens if the length of the arc is 2 pi r? Why I am taking 2 pi r is that I am considering the circumference of the circle. What happens when the length of the arc is extended around the circle? Then what is my angle? If you cross multiply and find it, then our angle will be 2 pi radians. Therefore, when I consider the whole circle as a sector, then the angle subtended by the whole circle is 2 pi radians. We know that angle subtended by a whole circle is 360 degrees. Therefore, 360 degrees is actually 2 pi radians. If I divide both the sides by 2, then I get 180 degrees is equal to pi radians. And this is the conversion we use to convert any degrees to radians or radians to degrees. 180 degrees is equal to pi radians. Let's continue and see if we can change degrees to radians and radians to degrees. Say for example, I have 30 degrees to convert to radians. How many radians is 30 degrees? Let's use the conversion equation. 180 degrees is equal to pi radians. So what is 30 degrees equal to? So it is 30 times pi over 180, which is pi over 6 radians. I said you don't have to write RAD. Pi over 6 means it is in radians. Let's see what is 75 degrees in radians. I'll be multiplying 75 degrees with 180 pi over 180, which will give me 15 pi over 36 radians. So the multiplying factor, as we can see, is pi over 180. Therefore, in order to change degrees to radians, the multiplying factor is pi over 180. Multiply the given degree by pi over 180, then you get the answer in radians. What about radians to degrees? If I want to convert, say for example, pi over 2 into degrees, pi over 2 radians into degrees. So I know that pi radians is 180 degrees. So how much is pi over 2 radians in degrees? Again, cross multiplying, we can see that pi over 2 has to be multiplied by 180 over pi, which gives me 90 degrees. What about if I have 2.4 radians to be converted to degrees? So I need to multiply 2.4 by 180 over pi, which is actually 432 over pi. If I substitute the value of pi as 3.141 etc., then I get this answer as 137.5 degrees approximately. Therefore, 2.4 radians is equal to 137.5 degrees and pi over 2 radians is 90 degrees. And we see that the multiplication factor is 180 over pi. Therefore, radians to degrees, the multiplication factor is 180 over pi. It is not necessary to remember this multiplication factors. You can just carry on with this equation every time. Try converting these degrees to radians. Convert to radians. 45 degrees, 135 degrees, 250 degrees, 315 degrees. Convert to degrees. I'm going to give you radians and you can convert them to degrees. Pi over 6, pi over 3, 2 pi over 5, 1.3, 2.5. As you can see, the radians can be either given in terms of pi, and if you substitute the pi, then the radians will be in terms of decimal numbers. So it is either in terms of pi or in decimal numbers.